Okay, moving on to homework problem number 4. This time a dog runs towards a stationary wagon at 9 feet per second and jumps into the wagon. If the dog weighs 50 pounds and the wagon weighs 25 pounds, what is the velocity of the dog and the wagon after the dog jumps in? You'll notice on this problem it doesn't even say to ignore the friction of the wheels. That's just something we're going to ignore. Friction, air resistance, all that kind of stuff, and just have this perfect conservation of momentum that we're going to deal with. So I'm going to go ahead and draw my picture first, my before and after, and then we'll go ahead and come up with the equation, and I'll put that on the problem page there. So we're going to have a before and an after. In this case, we've got a dog running towards a stationary wagon. I'm going to call the dog A. So we're going to make him a little bit smaller, and I'm going to make the wagon a little bit bigger. And here's the wagon B. Okay, so the dog's going to run towards the wagon at 9 feet per second. So that is my VA, and remember my before condition is my 1 condition for my formulas. Remember this word here, stationary wagon. Okay, you have to look into these word problems for clues like this. So this VB is going to be 0 feet per second. Now let's put some weights in here. The dog is going to be 50 pounds. And the wagon is 25. Okay, so that's what's happening. That's all we need to know for our initial condition. Initial weight and initial velocity for our two bodies for our conservation of momentum. Okay, after condition, I need to know my after weights and my after velocities. So after, I've got my wagon here with my dog in it. We're still going to have the same weights. They're going to be combined now, but I'll just put them separately. Wagon still 25, dog is still 50, so no change in weight, but we want to know what the velocity of the dog and the wagon are after the dog jumps in. So this is one of those inelastic collisions where we're only going to have one final velocity. So for this problem, my final VA is going to equal my final VB, and I'm just going to call it V, just to make my variables a little bit easier, because they're going to go together. They're essentially going to stick together afterwards. So now that we've got all our variables defined and our values, well, we don't know this one, that's my unknown, let's put it into an equation and see what we wind up with. So I'm going to go ahead and use that conservation of momentum one, and it seems like we're often using the one down at the bottom with the weights because we're being given initial weights instead of initial masses. So that's fine. We'll write that one out. We have WA VA plus WB VB, and that's my before condition, and that's going to equal my weight times velocity of body A plus my weight times velocity of body B in my after condition. And now we just plug values in for all of these variables based on the drawing we did or the way we understand the problem. So my A I called the dog, so that was 50 pounds, and its initial velocity was 9 feet per second. And as I'm writing this, I'm thinking, is that a positive or negative? So I don't think I did define that when I did my drawing here, so let's go back. I'm going to call everything that's going to the right positive in my before and after. So that would be a positive 9, and I'm thinking that this direction is going to be positive 2 for that velocity. Okay, so positive's fine. I've got the 50 times the 9. And then I've got the weight of the wagon here, which was 25 pounds. But its initial velocity, remember, was 0 because it was just at rest. And then in order to do this one, I'm going to combine those terms. Actually, let me write it all out and then I'll show you how you combine it when you do it. So I've got the 50 pounds times some unknown V. Remember, I was just going to call that V because they're both the same for VA and VB, plus 25 pounds times some V. And if you remember from the distributive property, we can put these together, add them together, and then just multiply that by V. So I'm going to rewrite this. I'm going to go ahead and put these terms together. This becomes a 0. 50 times 9 becomes 450 pound-foot per second. And then I'm going to put the pounds together here. I'm going to call this 50 pounds plus 25 pounds times V. Because remember my distributive property, when I write it this way, it's the same thing as taking this first term, multiplying it by V, taking the second term and multiplying it by V. So this way lets me combine the weights and just have that one variable there. I could also say 50 pound V plus 25 pound V is 75 pound V. That's okay too. But I just was showing you this shortcut because then you don't even have to write it this way at all. But it's kind of up to you how you want to put it together. I'm going to do another step here just to combine those terms to show that I do get that 75 pound times V. And then I'm going to divide each side by the 75 pounds to get the V by itself. So this will go away and my pounds will cancel. And 450 divided by 75 is going to give me the 6 feet per second. And it is in the same direction as the dog. Oops, I'm running out of space there. There we go. He's the only one who really had any direction to his velocity on this problem. So we can write that down. Or if, like I said, if you have your coordinate system shown, you know that that's positive. So one algebraic tip I will give here is to make sure that when you're dividing by the coefficient, if you have a sign in front of that number, you'll need to bring that sign over here. But if it's positive, it doesn't have to become negative to divide. Whatever's in front of the variable, when you divide by it, you just divide by that number. It's when we were subtracting in the other problem that we wound up with a negative sign. So if this doesn't have a negative sign to start with here, it's not going to have a negative sign when you divide by it. You're just dividing by that coefficient to isolate the variable, and you're just using exactly what that coefficient is. Okay, a little extra there. All right, that is homework problem 4. Stay tuned for homework problem 5.